Now, what if we have a rational function that looks like this? How can we graph it? So if you recall, the graph 1 over x looks like this. There was a vertical asymptote at x equals 0. But now it's x minus 3 on the bottom, so it's going to shift 3 units to the right. If you want to find the new vertical asymptote, set the denominator equal to 0. So the new vertical asymptote has been shifted 3 units to the right, so it's over here. The horizontal asymptote is still y equals 0. So the graph looks like this now. It's simply been shifted 3 units to the right. So what is the range and the domain of this function? Let's start with the range. The range could be anything except the horizontal asymptote. So the range is going to be from negative infinity to 0, union 0 to infinity. Now, the domain could be anything except the vertical asymptote. So the domain for this graph is negative infinity to 3, union 3 to infinity. What if the transformation is on the outside? Let's say if it's not part of the fraction. This number will cause the graph to shift 2 units up. So the horizontal asymptote will no longer be y equals 0. It's going to be y equals 2. So let's go ahead and graph the function. So the vertical asymptote is 0. That is x equals 0. But the new horizontal asymptote is now y equals 2. The shape of the graph will still be the same. It's simply been shifted 2 units up. So to write the domain of the function, once again, we just need to remove the vertical asymptote. And to write the range, we need to take out the horizontal asymptote. So it's going to be from negative infinity to 2, union 2 to infinity. So now what if we have a combination of transformations and reflections? Try this one. So if we set x plus 2 equals to 0, this will give us the vertical asymptote, which is negative 2. This number tells us the horizontal asymptote, which is y is equal to 3. And the negative sign tells us that it reflects over the x-axis, which for rational functions, it's equivalent to reflecting over the y-axis. So let's begin by plotting the vertical asymptote, which is at negative 2, and the horizontal asymptote, which is at 3. Now the graph won't be here because we have a negative sign. It's going to reflect over the horizontal asymptote. So it's going to look like this. And in the last example, we had a graph. The curve was here, but now it's going to be on the other side of the horizontal asymptote. It's going to be there. So to write the domain of the function, we just need to remove the vertical asymptote. So it's going to be from negative infinity to negative 2, union negative 2 to infinity. And to write the range, we can see that the lowest y value is negative infinity. The highest is infinity. However, it's not going to have a y value of 3. So we got to remove the horizontal asymptote. So it's from negative infinity to 3, union 3 to infinity.